Okay, so let's start. Welcome everybody to the Introduction to Godot workshop. Can you hear me well? ¿Me podéis oír bien por aquí en la clase? Vale, perfect. Well, first, some considerations. This workshop, as you probably know, will be in English because it's part of the Fair Game project and it's going to be streamed to several schools across Europe. But if anyone has any question and feels more comfortable asking it in Spanish or Catalan, it's okay. However, I'm going to reply in English because so everybody can understand my answer. But if you want to discuss more details, you can just ask me at the end of the class or write me an email, whatever is good for you. Well, as I said, this class is going to be recorded, and you'll have all the materials available on both Google Drive and GitHub, and also on my itch.io page. Did everybody receive the email with the assets and the?
Yeah.
Yes.
Aquí habéis recibido el email con las cosas de la clase. Vale. Okay. It seems that some part of the students didn't receive all the data, so I'm going to explain you. I'm going to explain here for this for you how to download it. You can go to my itch.io page, which is lyhdyr.itch.io. Wait, no sé. And if you go to Godot tutorial, you can download here the PDF and also the project. For the people in the class, in the call, I'm going to send you the link here too. I'm not sure if the connection is very good. I hope you can download it. So, well, while you download all the assets and all, I'm going to continue the presentation. First, a bit of an introduction about me. I go by they, them pronouns. In Spanish, uso ella, y en catalán utilizo ella. I'm currently producer, programmer, and character artist at the indie studio Lemon Bird, which is part of the pre-incubation and acceleration program in Power Up Plus. And I also have a wide variety of education since I first did English studies, then a master in gender studies, and later in life I decided to study programming. So I took a degree, well, programming and also video games because I always dream of being a game developer, but in the past there were not many options to study that. So recently I finished my studies in game development, but I've been making games on my own for years. I'm also an active member of FemDevs, the association that is organizing this event. And I have other kinds of jobs too. I work in a museum as a translation and mediator with schools. I've been a teacher. I've worked as a programmer in IT consultancies and other kinds of jobs. And also, I love to write, but sometimes, as you can see, I do a lot. I do lots of things, so I don't have much time to do that. And well, I also love cooking, watching series, and I have 5 pairs. Well, and here you can see my link tree if you want to see my portfolio, social networks, and all. Uh, well, now let's talk a bit about what is Godot and what is good about Godot. Uh, Godot is an open source game engine that allows you to develop games in 2D and 3D. And you can export them to different platforms like Windows, iOS, Linux, Android, web, and also if you have the development kit, also to consoles too. So basically, you can make any kind of game with Godot. What does free and open source mean? It's a kind of software that it has its source code available to all users, so they can just study the code and see how it's made. They can modify it, and even they can contribute to improve the software that it's available to other users. So basically, the idea is that this software is not just made by a company as a product, but it's something that it's built by all the community. We can find other examples like Blender, GIMP, Mozilla, Firefox, LibreOffice, and VLC Media Player, etc. There are many kinds of open source softwares, and they typically are free, but they can, depending on the kind of copyright, they can also be commercialized. But well, in particular, Godot is free to use and it's open source, so you can contribute to it and see how it's made. Other interesting points of Godot are that it has a very clear and complete documentation, a very strong community, which, as I said, it contributes to improve the engine by reporting and fixing bugs. Many people also implement new features or just write the documentation. So Godot grows as the community grows too. The idea is it's an engine that has a lot of shared knowledge and a strong community around it. Regarding the characteristics, it's very lightweight because, for example, this version that we're going to use, the 4.3, it's only 126 megabytes compared to, for example, Unreal Engine, which is hundreds of gigabytes. There's a lot of difference. So if you don't have a very high-end computer, you can use Godot with no problem because the requirements are not very are low compared to Unreal Engine and even compared to Unity. You don't need to register anywhere, no, so you don't have to log in to start using Godot. You don't need to even install it. You just download it and execute it. And well, there are no license fees, no subscription fee, and no shady clauses. You don't have to sing anything. So, as you know, for example, with Unity, there was some controversy because they changed clauses. But here, you won't find this kind of problems. And I think it's quite intuitive and easy to learn compared to other engines. So it's a good place to start if you want to make games. If you want to download Godot, it's very simple because you just have to go to their official website, godotengine.org, or just, if you don't know the website, you just Google Godot. And it's the first thing it appears. And you can just click download latest or look for other versions. And if we click here, as you can see, well, you can also contribute to it. and it just downloads. And you have here a zip file, which if you extract, well, as you can see, you have two files. This is the one you usually use, and also one with system console. So that's all. Basically, in order to use Godot, just download it, extract the files, and click on it. But first, let's continue with more Godot basics and concepts. Now, soon we are going to make the tutorial. So let's review some concepts first. Godot, everything in Godot is made of nodes. Nodes are the basic unit in Godot. And you can combine them as you want. For example, you can have a node that is a player and which has an animation, a collision, and this combination of nodes are called scenes. So you made your own nodes, parent nodes with children nodes, and then you save them in the Godot file system, and you can reuse them as you want. For example, you create an enemy, and you can then spawn this enemy many times, or you create a tree, and you can reuse the same tree as many times as you want. And well, this concept of tree system is also important because, as you can see, everything is like nodes and children nodes, and it's organized like that. Even the game scenes, the levels are also organized like that, and there's everything are nodes basically. And we have many types of nodes, like the node, which is the generic one, timers. This one is auto stream players for music, buttons, labels, sprites, textures, animation players, cameras, collisions, and many others. And you can also make your own kinds of nodes. And there's a lot of documentation. So if you want to know how to use a particular kind of node, for example, animation, you can just animation player. You can just look it up on the Godot documentation, and there's a lot of information on that. Very useful. Nodes sometimes have their own signals. A signal is something that a node emits to inform that something has happened. For example, if you have a timer, when the timer reaches its timeout, it can emit a signal, so you can know that, for example, 1 second has passed. Or if there's a collision, you can know by using a signal that something has entered that collision. It's very useful if you want to know if, for example, the player has received damage or has picked up an object, etc. You can also make your own custom signals, which is also very useful. Then when we want to define a node's behavior, we use scripts. Basically, we code to make things happen. Godot has its own scripted language, which is GDScript, which is based on Python. It's compared to other languages, it's very simple to use, and as I keep saying, there's a lot of documentation on how to use it. And well, Godot has also official support for C# and C++, and all other third-party integrations for other languages like C, Rust, D, Python, Nim, Go, Lua, etc. And you can combine these languages in the same project for different purposes. For example, you could make your game with most of it with GDScript, but then for optimization, use C++. But it's important to know that since Godot's own script language is GDScript, it's the language that has the complete support. Other languages might not have full support. For example, if you want to export games to web, you won't be able to do it in C#. So it's better, it's good to know the limitations of that. Then, to script, in order to code, Godot has its own IDE, which is the Integrated Development Environment. If you are a programmer, you are familiar with other IDEs like Visual Studio Code, Visual Studio, etc. But here you don't need to install another one. You can use the one that Godot provides, which, as we will see later, it can be easily accessed from the script tab. If you prefer it, you can use other IDEs just by connecting the project and downloading the package is necessary for that. But here in this class, we're going to stick to the Godot IDE. Other important concepts that it's useful to know are the resources, which are basically the data containers, which can be animation, meshes for 3D models, textures for image, themes for A-style, for example, to define the buttons A-style, like its font, its size, etc. Audio streams for audio, but you can also create your own custom scripts or custom resources by defining them on a script. For example, you could make a resource that contains the information for an item, which its name, the item's description, the item's image, its price if you have a shop system, or for an NPC, the name of the character, its role, the role, etc. It's very flexible. So well, let me see. Okay, now we are going to continue with the tutorial project. So we are going to start making things in Godot. So does everybody have Godot on their computer right now? And the assets, the AS.
Yep.
If someone doesn't, can you download it now? Well, now there's going to be a lot of information. I'm going to try to be slow and adjust to your time, but if I'm going too fast, let me know. And also, if you get lost, just remember that this class is going to be recorded and that you have all the explanation available, so you can just review it at home with more time. Okay, let's start. The game that we are going to make is a simplified version of a game I made some time ago for the San Jordi Jam. I made it in April 2024, and it's a game called Martina la Dragona Revolucionaria. It was a kind of crossover between this anime called Utena and the Legend of San Jordi, and it was an arcade kind of shmup game with some arcade elements. We're going to make a more simple, a quite simple version, where we're going to have a player, which is a dragon, a level with a parallax background, so as you move, the background move with you. Obstacles that hurt you. Also, there's a game over. Some time to see how much time are you playing. Are you surviving? Music, and I'm going to also comment a bit about how to export the game. I'm not completely sure we are going to be able to do all of this during the class because it depends on how much time you need to follow the class. So if we can't, you'll have all the explanation here on this PDF. So first, I'm going to open Godot. If we want to create a project, we click on Godot and it opens. We have this menu here where we can see projects that we have already made. We can manage them, we can change their name or remove them. We could also look for other projects that we have on our file system. And we can also access the asset library where people can upload their own assets and share them with others. So to create a new project, we click on this icon, create, and we name the project Godot tutorial, for example. And here we choose where we want to save this project. For example, here, Godot. And we can see here the path and the project name. Here, there's also how we want to render the project, but don't worry about that. We can leave it on forward plus. It's the default rendering system. And we could also, well, here we have some metadata for Git. We don't need to change that. And then we click on create and edit. We have to wait for some seconds while everything is loading. Okay, now here we have the Godot's interface. Let's see a bit what the different elements. Here we have the scene with, well, we can click new, save, project where we can change the project settings. So we can also export from here. Debug for some to be able to see some debug elements that help us see what's going on the editor. Another parameters here help. These are the tabs that allow us to change between 2D and 3D viewport. This is the IDE. Here there's nothing because we haven't created any script now. And here is the asset library where we can download assets other people has made. And here we have buttons to test the scenes we have made, basically play button, or if we want to run a specific scene. Here there's the tree system where we create the nodes and manage them. The file system where we can see all the files and folders from our project. The viewport, here we see what we are doing, depending on the tab we have chosen. And also we have the inspector, where we have information about the node we have clicked, we have selected, and its properties and all. Node, it's a bit confusing, this name, but this name is a bit confusing, but here we can find the signals, like when a timer has reached timeout, for example, and story the history about our node. Also, here we have, mm, for now, the most important one is the output tag, which opens the console where we can see the bug messages like errors or prints that we write. But so well. Uh, First thing, uh, before creating any nodes, should be to uh, create some folders to have everything organized, because projects can scale very easily, and it's recommended to have things tidy, in separated in different folders, because if you don't do that, it's a mess. And then if you try to do it later, you can find some problems with references to to files and well. So let's create some folders. We click here, right click, create new folder, and we are going to call this scripts. Mm, Another one for scenes, and we would need a third one named assets, but since we have already, you should have downloaded the assets folder, well, the tutorial project. You have here the assets folder. You can just copy it and paste it. Well, you can copy and paste it on the path where you have created your project, or you can just drop it here. So well, we now have all the art and audio, fonts, etc. So well, mm, how are you going? Is everything clear? Okay, so let's continue. We are going to create our player. Uh, so here we go. We choose 2D scene because it's a 2D game, and we have now a node, a 2D node as the root of our scene. We can rename it. If we right click on it, we can rename it to player, and we save it with Control S, and we can save it on the scenes folder as player. So now we have our first scene. Let's add some more things. For the player, we're going to change its type to, so well, right click, change type to character body. This is a kind of node typically used for characters like players, that has some pre-made elements. Um, and well, now when we change its type, we notice that there's a warning here. It says that it has no shape, so it can collide or interact with other objects. So, and it says, consider adding a collision shape 2D or collision polygon 2D as a child to define its shape. Let's do that. Uh, mm, we right click and add child node, and here we type shape, and let's choose collision shape 2D. But
Sorry, I have a question.
yeah,
Can you please repeat what you did earlier? Like after you renamed the 2D node to player, I missed the thing which you did, like which you changed to the character.
Yes.
name.
Okay. You right click on player, change type, and here you search character,
For
and
me,
choose.
I can only see Node 2D in my screen. Like I can't find the character node.
Maybe you are, for example, if I do this now, I can only see character body. Previously, it was like this. You have to
Okay.
delete this and write character.
Okay. Thank you.
And okay, someone is asking. Okay, define. No. Could you change the language of your project? Perfect.
And sorry, after that, what did you do? Like after changing the character node?
Uh, I right click on player again and choose add child node and then uh, shape, choose collision shape 2D because the player needs a collision to function.
Okay, thank you so much.
And now let's add another node because if we now we can see the player. There's nothing on screen. So let's add. We could add a sprite or an animation sprite. Here we're going to add an animation sprite because our player is a dragon that flies. So we want it to fly to move its wings. So let's choose animation. Uh, it's no, sorry, sprite. It's animated sprite 2D. So, well, both nodes have a warning because collision shape 2D needs a shape. We have to define the shape the collision has. And animated sprite 2D needs sprites to work, sprite frames, because now we don't have anything. So first we are going to make the animation, and then as when we have the animation and we're able to see the dragon, we are going to define a collision shape because right now we don't know which shape the dragon has. So let's click on animated sprite 2D, and here on the inspector, where we have all the properties of every node available, well, of the selected node available, we go to animation, animated sprite 2D animation, and we choose and we click on spread frames, which now is empty. We don't have any animation defined. We click on new sprite frames because we have to create it from zero. And click again on the newly created animation frames. And you can see that this window opens here. Here is where we define the animation and how it works. So now, in order to create our animation, we click on this grid icon, which is called Add Frames from Spreadsheet. And as you can see, we see our file system, and then we click on Assets, Art, and we choose the dragon animation. This is an image that contains all the frames for the animation, but we have to correctly split it in order to use it. As you can see, now it's not split it in the right way because it has too many cuts, too many cuts. So let's change this parameter to 1. Let's see. I, I click enter. Now we have 4 frames correctly separated. And in order to create the animation, we click on all of them in order, 0, 1, 2, 3, from left to right. If you may, in other projects, you may have this in a different order, so you would click it on the necessary order. But here we go from left to right. And then we click on add 4 frames. How imported? Okay. Yes. To import the dragon, I click here on this icon, which is like a kind of grid. And I went to Assets, Art, and click on the dragon. And then I'm going to repeat it again. And then I change it here to 1, so there's only one row and 4 columns. And I selected all of them in order and click on add 4 frames. Okay, now we have all the frames and we change its speed. Can make it a bit faster, like 10 FPS maybe. And then we click on this icon, which is called autoplay on load, so it plays. Here we could do other things like add more frames, duplicate them, or delete some, sorry, or rearrange them, also define more animations. But for now, we only need to change the speed and to click on autoplay. And now, okay, let me see. The dragon should be flying. Okay. If we want to see it on the inspector, we click on play and we can see that the dragon is flying. Now that we can see the dragon, we are going to add the collision shape. There, if you click on collision shape, now on the inspector, you can see all the properties too. So you here you can choose between different kinds of shapes like circles. Well, you can also segments, rectangles, capsules, different kinds of polygons too, or load a predefined collision. So the kind of collision we define is a matter of design, because depending on how we want our game to work, we could add bigger or smaller collisions. We could the collision could be on the wings or only on the body. This decision is about design. So here for this game, we are not going to make it very difficult. We are going to limit the collision to the dragon's body and head, but we are not we'll leave the wings without collision. So we can create, for example, a capsule shape. Well, if we rearrange this, we'll see it better because the collision was under the dragon. And we can change the size with this by doing this, so it more or less matches the dragon shape. And that's all. We have now defined the dragon's collision. Uh, Now, well, this is not very important right now, but it's interesting, especially if you are making pixel art games. You can see that the dragon is a bit blurry, right? Uh, we can make the sprites more defined, more crispy. If we go to project settings, and then on rendering here, we go to textures, and here we have this parameter default texture filter. We choose nearest, and we click on close. And now you can see that the dragon looks crispier. The pixels of the sprite are more defined, and this we have this kind of pixel art aesthetic. So well, we have created our dragon with its shape, and it looks better now. So let's add some movement, because the dragon is the player. We want to be able to control it. And in order to do that, let's click on player, right click, and attach script. We could also do this with this icon here. Uh, just a comment. If you are not sure about something, you can just leave the cursor and you can see that there's a message here. For example, it says attach a new or existing script to the selected node. So it's very useful. We click on this, and here we have a window where we create our script. I know I said that we changed the nodes type to character body to character body in order to have some pre-made stuff, but for now we don't need this template because it's a bit different from what we want to do. So we just click on default, and then here we choose. We want to keep everything tidy, so we choose our scripts folder and save it as player.gd. Oops, no. Okay, here we have this. So we click on create. Okay, thank you very much for writing this path to change the texture rendering mode. Let's continue. Wait a second, because I have here something that it's making some noise, and it's a bit of annoying. So, well, now that we have created our script, the Godot's IDE opens. It's this tab script, and we have a template. Basically, well, this our script extends from character body to the, which means it's it has kind of the behavior of character body, but with some new stuff that we are going to add or redefine. And by default, scripts in Godot have these two functions. One is called ready, which is the things that execute when the node is firstly created on the scene, like when the node first appears at the beginning. And then this one is called process, and it happens every frame. Frames typically are not regular. They can, depending on the computer, can repeat at different rates. So there's this variable called delta, which is used to control how much time has passed between frames. I know that if you are not familiar with coding, this might be a bit confusing. So don't worry about that. Let's go step by step. Um, so well, in the PDF I shared with you, there's the final code that we are going to write here. But if I'm typing too fast, you can just copy and paste it. So just to keep everything clear, I'm going to name this player, but this is not that important right now. And well, we want our dragon to move at a certain speed in some direction. So we need two variables that are speed, which is a kind of float. Float is a number that has decimals. And by default, we can set it to 100. And then one direction, which is a vector 2D. A vector 2D is, it contains two coordinates, the x coordinate in the horizontal axis and the y coordinate in the vertical axis. Because we want, this is a 2D game, so there are only two axes. And we want the dragon to be able to move in all directions in the axis. So well, in order to be able to capture the inputs that the player does, we use a pre-made function that it's called input. Well, pre-made, I mean, it's a built-in function. It's part of Godot. If I type func input and press tab, it autocompletes because it's built-in. It's part of Godot. Let me type this first. So well, the direction will be defined by the input the player does. In this case, the input is going to be the arrow case in your keyboard. And here we can use this function which is called getVector, and we define which keys are the four directions. And in Godot, there are some pre-made inputs that we can use. We can also create our own ones and define them, but we are going to write here these ones that you can see in the PDF too. UI left for the left arrow, and UI right for the right arrow. UI up for the up arrow, and UI down for the down arrow. So basically, we write them in this order, and the direction vector depends on the arrows, the keys that are pressed. And then, well, we don't need the ready function, so we erase it, we delete it. And since this is about movement, and we don't want we want it to be stable. We don't want to make jumps depending on the computer and go at different rates. There's an alternative to process which is called physics process, which is usually made for physics calculations like movement, gravity, friction, this kind of stuff. Uh, so, well, we calculate the position by adding the direction. Position is also a vector, which basically it says where are you in the x and the y axis. So we added the direction to the current position, and which is multiplied by the speed and also delta time, because if we don't do that, this part, the dragon will move very fast. We want it to move according to the time that has passed. So we can delete this, and that will be all. But we can also, if we want to be able to modify the speed on the inspector, we can also add this export. So now, as you can see, speed appears here, and it says 100 because it's the predefined value that we have, the default value that we have assigned. As I said, if this is confusing, don't worry, because I know if you know nothing about coding, there's a lot of information here. So just copy it and let's see how it works. How as we change stuff, the player does things. In the first line of code, class name player extends. No me parece speed en el inspector. A ver. Let me see. This one is red. It's normal. Godot uses different colors to make it easier to understand the different elements. So words that are part of code like class name, var, which means variable, extends, function, func, I mean, are always in red. Then these kind of tags that of labels that we add to modify the variables usually are in orange. The variable types are in green. Strings are in yellow. Functions can be in blue. So yes, it's completely normal. The class name is red. A red bar over to functions. Yes, another important thing is, maybe I went too fast. You can see that code here has a space. It's indentation space. In Python and JavaScript, which is a derivation of Python language, we define the different areas of the of code and which thing is part of another thing with indentation. So when we write stuff inside of a function, we need to add an indentation here to indicate that this is part of this function. I don't know if that solves the problem. And vale, no aparece en el speed en el inspector. Are you selecting player? In order to see speed, first you need this export label, @ export label, and player needs to be selected. If I choose another thing, for example, animated sprite, I can see speed. I need to have player selected in order to see its properties. Sí, guardar puede ser. Sí, yes. Save, so changes are applied. Okay, now that we have written this code, we want to test it, right? But the dragon doesn't have a place to fly, so we need to create um, an area where the player can fly. So let's create the level. We go back to the tab. So we are able to see the 2D viewport and the level. And we click here on add a new scene. This is like, as we did with the dragon, here we have these different options. And this is a 2D game, so we choose 2D scene. Now, we don't have to change the node type, but we can change its name. We can rename it or just double click and write game. And we save it on the file system in the scenes folder as game. And now we can just, from our file system, we can just choose our player scene and drop it here. And now, as you can see, player is part of the game scene. If we click on display icon, it will say that no main scene has been defined. So we select current, which is the game scene. And as you should be able to move your dragon now.
Sorry, can you repeat that?
From when do you want me to repeat?
How to move the dragon like that? I imported the player scene into the scene. So,
Yes, you play and you use the arrow keys from your keyboard.
okay.
And well, you can see that the dragon is a bit slow. So with the speed variable that we have created, we can change it and write, for example, 200. And let's try. Now it moves a bit faster. Depending on the game, we would want it to move even faster or slower. We can leave it to 200 here. I think it's fine. Remember, here we click player and change this variable to this property to 200. So well, another thing that we can do is to change the size of this viewport, because well, this depends on your game and what do you want to do, what you want to do. I personally choose to have it smaller. So to do that, we go to project settings, and then here on we display window, we can define here the size. It could be a 4K game. It could be full HD, whatever, or smaller sizes. Here, I'm going to define it as 648 and 480. Basically, because it's the size the sprites have, the background has. But in your own games, you can choose something different. But for this, so well, remember it's here on display project settings, display window, and let's put these values. So now you can see that the window, the, uh, it's not very visible, but you have a kind of rectangle here, a blue rectangle that defines the window size for your game. And while the dragon now it's in the corner. So by using these arrows, we can move it and place it on the center, for example. We could also change its position on transform here on the inspector and write whatever we want. Remember to keep saving your progress, so if there's any problem, you don't lose the progress. So well, we have our level, but it's kind of boring because it doesn't have anything apart from a dragon. So let's add a background so the dragon has a place to fly. As I said at the beginning, this is going to have a parallax background. Parallax background means that the background moves. It scrolls in a direction, so it gives the effect that you are moving, that it feels more that the game has depth. And well, basically here we're going to use this to make that it seems that the dragon is moving on an endless space. So we click on game, right click, add child node, and we are going to need these three nodes. The first one is parallax background. We need to put it first because the player is on top of that. The elements are rendered in the scene in the order we define them here. So first we have the background and then we have the player. Now we right click on parallax background and we add parallax layer. This is because a parallax background can have different layers to add depth. You could have maybe some trees and then some mountains and then the sky. So it could have different layers that move at different speed. In this tutorial, we are only going to have one layer, but I comment this for you to know. And this layer needs a texture. And on texture, we add the image that is going to be our background. So we click on load, and this is on the art folder. It's called parallax. And now you can see that there's some kind of floor here, some kind of field where the dragon flies over it. And texture rect, and now we go to no, we load because we already have a texture in the art folder. So we choose, we go to assets art folder and we select parallax because we don't create it from zero. We choose one that we already have. We select texture rect, and then here the this is empty at first, so we click load, and now art. On the art folder, parallax, parallax.png. So well, we click on play to test it. Uh, and you can see that the dragon uh, goes outside of the window. So let's fix that. There are multiple ways to approach this. For example, in the original version of this game that I did for San Jordi Jam, what I did is that I set limits on the space, so the dragon couldn't move outside of the window. And I moved the parallax by script. But here we are going to do another way, which is simple than that. So, well, first the camera is going to need sorry, the player is going to need a camera. So we click on player and we add a node, which is camera, and this is a 2D game, so camera 2D. Now we have a camera that follows the player, so if we play the game, you can see that the camera, if we move, the camera follows the dragon. But as you can see, the background is limited to this size, so we go outside of the background. And we don't want that. We want it to repeat, so it seems as if the field is infinite. So we go to parallax background, no, sorry, parallax layer, the second one, and in motion, here in the inspector, there's this property mirroring, which is the one that allows the parallax to repeat itself. We are going to define the size of our game window, which is the same size the parallax has. And by doing this, we define that it repeats on both the horizontal axis and the vertical axis. And if we test it, we can see that now the dragon flies on an endless field.
Sorry, how can I open the camera tab?
Camera? Yes, you go to player, right click and add child node, and here you search for camera and choose the camera 2D. So now the player has a camera as a child node. Since it's a child of player, when you move player, the camera moves too, because it's part of the player. And uh, here, you could also add the camera here, but well, the hierarchy here is animated player, and then you have animated sprite and collision shape. I added the camera in the game, but the camera could be on player too. The code from player, yeah, it's here. You have it on the PDF too. Lo puedes ver en el PDF, que te será más fácil. Okay, to see the script you have assigned to the node, if you go to player, you can see that it has a script icon here, and if you click on it, it opens. Nodes have, you can see if a node has a script if it has this icon on it. As you can see, player has a script, but these ones don't have one. And there are no scripts on game, but you can see that player has one. You could add different scripts in different nodes and combine them to do different things. Well, because it's a player is a child of game, and camera is a child of player. But the difference here is that if you add the camera inside of the player scene, every player that you create will have a camera because it's part of the scene. If you do it from game, the camera is on this player, but if you created another player, it wouldn't have the camera. But yes, it depends on what you want. Here it doesn't matter because we only have one player, so you can do any of that. But for different elements, it could be interesting to add nodes from the game scene or add them from their own scene, depending on what you want to do. Okay, so we at first we planned to take a break at 11:30. I don't know if it's fine for you to do it now or you prefer to do it later because we started a bit late. Okay, so we are going to take a break until 12. So you can, if someone got lost, you can review the PDF and see if you can find the answers there. Or you can just have breakfast or go to the bathroom or whatever you need. So let's see later at 12. Yes, the background is in the center of the scene. I see. Well, the background is actually, let me see, it's on position 0, 0. Since it's the same size of the screen, it matches the scene. Well, check your check the PDF, and if you need help with your dragon, let's see it later. Okay.
Is it still sharing?
Uh, yes, I'm sharing, right? If you, I think the problem is that you choose this scene as the main scene. So now when you click on this, it executes this scene. You can do two different things. You can, for example, if you click on this, you execute you run the current scene, which here is game scene. But you could also change the default scene in project settings. Let me see. In run, application run, you can select here the scene and select game. And this is the default scene now. So does it work for you? Great. To the person who was asking UI app instead, UI double B wouldn't work. Let me see your problem here. Event 6. Okay, warnings that don't worry about warnings. Error, no. Class name player. I mean, if you see warnings on your code, it's not important right now. Okay, I'm going to see if the in-person students come here. No, my dragon still doesn't move. I my dragon drops down quickly as soon as I hit play. That's because you have you probably have the character body script here. Instead of that, copy this code and also make sure that, let me see, collision. No. Well, grounded. I think that it drops down because it has gravity. Because on the template code there was some gravity because it's meant to be on a kind of side view scenario, not on this top-down scenario. So yes, you only need this code. You can, if you have more functions on your player script, delete them. Okay, seeing that maybe you didn't click on autoplay. On animated sprite 2D, we have this icon here, autoplay on load, that we need to click it in order to have the animation play from the start. If we don't if we don't do this, we would need to play the animation from script. So it's this icon here on player, animated sprite 2D, and autoplay on load. Great. Now we are waiting for the other students to come. So I don't know if anyone has any other doubts that we can solve in the meantime.
I had a question.
Okay.
It's not exactly related to the coding and stuff, but for the artwork, is this software like compatible with Photoshop files to like import like your art?
Are you asking me if you can modify the art?
Like, is it compatible with Photoshop files?
Yes, you can create your own Photoshop files, your own art in Photoshop or whatever other art software you use. You just need to export them in PNG format, so they have the transparency.
Okay. Thank you.
I mean, Godot is the engine where you make the game, but then you make art on other software. I usually for pixel art I use Sprite. I'm going to type the name here. Uh,
Okay.
is pixel art, but when I do more kind of illustration, I use Procreate, but other artists use Clip Studio, Photoshop, or Gim, Krita, Inkscape.
Like, do you know any website or place where I could learn other kinds of codes for like player actions.
Or create a, can you repeat? I'm not sure if
Sorry,
I.
I was asking, like, do you know any websites which where I could find other codes, like, and learn codes to make other kind of player actions, like,
Yes, player actions. Yes. At the end of the PowerPoint, I I added some more links. Here you have more tutorials
Mhm.
from different video tutorials, and also you have the Godot documentation, and you can easily find if you type, for example, Godot for I don't know, a shooter tutorial. You can easily find.
Okay.
There's a lot of content because it has a large community,
Mm-hmm.
and you can find different languages, different formats, video, articles.
Okay, thank you.
Okay, I think that everybody's here now. So, in order to make the game more interesting, uh, because now we only have a dragon who is flying on a field, but nothing else happens. We could also kind of enemies or obstacles that we have to avoid. So um, let's create a new node, a new clicking here at a new scene. A new scene. This is again a 2D scene, and we can rename it. I name it as obstacle, but it isn't really an obstacle because it moves. You can name it enemy or uh, tornado because it's kind of something that spins on the screen over in your direction. Uh, we name it, for example, obstacle, and this time we wanted to uh, change the type to area 2D. This is a kind of collision object that lets other objects go through it. The idea is that since there are many obstacles on screen, mm, they don't they can cross they don't collide like a wall. Um, we select area 2D, and again, and since this is a collision object, it tells us that we don't have a collision shape. So this is very similar to what we did with the dragon. We need to add a shape, a collision shape 2D, and we also would need an animated sprite. I'm going to reorder like this. First the animated sprite and then the collision shape. And again, we need to define the animation and we need to define the shape. It's better to do first the animation because we are able to see it on the screen, and then to add the shape. And so as like we did with the player, we select animated sprite, and on sprite frames we create a new one, and we click on it, and here we on the grid we select the spiral. It's like a tornado, uh, and again we need to properly split it So it has 4 columns and 1 row. And we select all the sprites, all the frames, and add 4 frames. And again, we change the speed. So, well, this is more personal. You could make it move faster or whatever. I'm going to write 10 here. And we also click on autoplay, so it plays since the beginning when you execute the game. And well, if we want to see how it works in the inspector, we can click on play, and well, it's this thing. Just a comment, we don't really need an animation. We could do this by code by making the sprite spin, but well, this is more simple. So well, we have this animation. I don't know if what is the parent node called? I named it obstacle. You can name it enemy, tornado, for as you prefer. And you have to save it. I say we save it in the scenes folder. Okay. So, okay. Can you repeat the input of image? Yes, like we did with the player, we create an animated sprite. Create a new sprite frames, and then we, on the grid, we select the spiral, and it has 4 columns and 1 row. We select them all and add frames. And then here we add, we write 10 FPS and autoplay on load. It's basically the same as like we did with the dragon, but with a different asset. This is called spiral.png. PNG, sorry. But it's exactly the same process. And the kind, yes, as Red said, the type is area 2D. Now for the collision shape, since this is a circle, we choose a circle. We click on collision shape 2D, shape, and new circle shape 2D. And well, there's a problem here because it's basically the same color. So we can change the color of the collision so it's easier to see in the back color, for example, purple, or whatever color you prefer. And here we can change we can, with this red dot here, we can change the size so it matches the shape. So, well, now we have our obstacle. And the obstacle, okay, let me see. The obstacle will have a movement towards the player. And we are going to need 2 different scripts to do this. First one, in obstacle, we create a script. We can do this, remember, by right-clicking and attach a script, or just selecting obstacle and clicking this icon. Again, we save the script on the scripts folder, and we don't need to change this. It's fine. So we create it, and well, you have the code for this on page 36. But basically, again, we can name it obstacle, and we are going to need a direction. It's very similar to the play. Well, to the player. We need speed, which is again a float. A number with decimals, and also a direction, which is a vector, to coordinates. So we are going to do it different because the player is an element that we control with input, with the arrows from the keyboard. But here, this is an external element that we don't have control over it. It comes and it tries to touch us. It's basically an enemy. So we are going to first to define the speed. We are going to do it randomly, so different obstacles have different speeds, and there's more variety on it. To do so, we here speed. We use this function that you can see on the PDF. It's randf range. This is a function that returns a float between a range of numbers. For example, with the 100, which we saw earlier that it was a bit slow, and 300, which is faster than the player. But you could write here whatever numbers you prefer. And for process, again, we are not going to use process, but physics process, because we want that it moves in a stable manner, not depending on frame rate, which can vary. So, like we did with the player, we calculate the current position in every frame by adding the direction in which the obstacle moves, multiplied by speed and delta time, the fraction of time that happens between two frames. Delta time is usually milliseconds, like very small fractions of a second. This is the same formula that we use with the player, but here direction will come externally when the obstacle is spawned. It's created. And well, let me see if there's a question. Like we did with play. Yes, the thing. Okay, so let's go to the game scene, which is where everything happens. This scene will also be in charge of creating the obstacles as time passes. So we're going to need to do some first steps before we can actually spawn the enemies and make them move. First, in game, we create a new script. This is again saved in the scripts folder, and it can be called game. I call it here game manager, but game is fine too. In the end, it's the script that manages the game and the game rules. So, well, game manager, okay. Manager. The game manager will need to have access to the player. So there are many ways to do this. In the PDF, I did a different thing, but the easiest way to do this is that we select the player, click Control, and then we Okay, we select the player, and then here we click Control, and then automatically we have this reference. It's a variable player with a reference to player. And it has this label, which means that this reference to the player in the game is got on when the script starts with the ready function. Yes.
Sorry, I got lost in between. Can you please repeat what you did?
Here we need a reference to the player.
Like, I got lost when you came back to the game script
Yes.
because in obstacle script there was like some errors and I wasn't
Ah,
able.
okay. We click on game, the parent node, the root of this scene, and we attach a new script. And this script is this one that you have on. Well, you have it on. Let me see. Well, it's on slide 29, but the one on slide 29 has more content, but we'll get there. But, well, this script, I call it the class game manager. And for now, I just click on player, drop it here, and then press Control. So this line is generated. You could also write this manually or copy it from the PDF. But this is an easy way to create this reference automatically. This is basically when nodes are inside other nodes. Well, we can get an easy reference to them. We can also, sometimes this can get more complicated. For example, if I try to add a texture rect, as you can see, the path is longer because it has to access all the nodes in the hierarchy. First, the parallax background, then the parallax lawyer, and the texture rect. So this is just information to know, but don't worry much about that. But you could make a node unique. So instead of having to write all the path, you could access it by its name. But it's just extra information. Don't worry much about it. The important part here is that we have a reference to the player.
Sorry, I couldn't find the code in the slide 29.
39.
Like, I couldn't find the code in the PDF.
Yes, because the code in the slide 39 is longer. It has a lot of content here that we haven't arrived there yet. So but it's basically this part here.
Okay.
Here, it has this percent symbol because in the tutorial in the PDF I did this thing I just commented of access as a unique name in the player. But if you don't do this, you have to write a dollar symbol.
Okay.
So, well, we have a reference to the player, and well, we will also need to know the path to in the file system to the obstacle which we are going to see now. But basically, when you need to know the path to something, you can go to the file system, right-click, and copy path. This is useful when you need to write, for example, not only for code, but for the inspector, or different situations. But just for you to know that if you right-click and copy path, you have, as you can see, the complete path to that element.
Okay. Sorry, I just had another question.
Yes.
In my obstacle code, I keep getting this error which says I have a mixed use of tabs and spaces, and I tried to add spaces and it makes the error worse.
Yes, always use tab, not the spaces, because the spaces uh, will give you an error. Always tab. So the code is structured like this. If something is inside a function, it must go with a tab. So the code
Uh,
knows that it's inside, not the spaces, because if I do this manually, it won't recognize it, and now it's complained. Just tab. So if I fix it, I can fix it by just tapping at it, and then there's this space, and the now it recognizes that this is part of this function.
okay.
So, well, another element that we are going to need is a timer, because we want elements, obstacles to spawn, to appear on a certain time. So we click on game, add child node. We could also do this by clicking this icon here, the plus icon, and we create a timer. Now, this timer, we go to node, and remember that I said that there are signals that tell us that something happened. So we have this signal called timeout that tell us that a timer reached its timeout. For example, if a timer is 10 seconds, with this we know that 10 seconds have passed. So we select timeout and we right click on it and click connect. And now we need to make sure the game node is selected, because this is going to be done by the game manager script. So we do this and we connect. And now, as you can see, there's a new function here on timer timeout. This is what happens when timer reaches its timeout, which we haven't defined it yet. So now, before continuing, we can configure our timer on the inspector. We have to select timer and go to inspector. And here we have different parameters, properties. For example, wait time is how much time the timer lasts. In this case, we could write 1 second, half a second, 2 seconds. This is also something that you can keep testing to adjust to the time that best suits what you want. Here we can write half a second, 0.5. And now we have other parameters. One shot means that the timer only runs once and then it stops forever, unless you call it by code, which could be possible too. So we don't want this. We want that timer keeps keeps running again and again and again and again. So every time it reaches timeout, a new obstacle appears. And we also want that it does this automatically, that we don't have to worry about starting the timer. So we click on auto start. So now we have our timer configuration. And let's go to code, which it's going to be a bit complex. So again, don't worry if you don't understand everything. But let's go step by step. Okay, so we have this area here that is the viewport area or the game window, the things that you see through the camera. And we want objects to appear a bit away from that, outside of the window, but not very far away, just in this area here. So we will need to, on one hand, we need a vector too, which is the coordinates that define the size that define your vapor area, which are these numbers that we defined it first. But it's better to do it like this, because if you want to change the size of your window, it will work as well. If you manually write the values, you will have to change them every time you make changes in your game. So this variable will store the size of our viewport, of our game window. This other area here will be the area where the obstacles appear. And offset is basically the size, basically. You can see it's this size here, which will be the same in both axes, in the horizontal axis and the x-axis. I define it as 50. This part here is what we already saw, the reference to the player. Again, it has a % symbol because I did this. Access as unique name. But if I don't do this, it's a $ symbol. And we will also need to be able to load the obstacles scene. So let's see. First, we have. I'm going to do it manually so you can have time to understand everything. Viewport area, which is, as we said, it's a vector 2D. And the spawn area, which is also vector 2D. These are the vertical and horizontal sizes. The width and height, basically. And we will also need, we can write const, as this is something that never changes. It's not a variable that we need to store things that may change in the future, but it's always the same. So this is called obstacle. Typically, constant variables are written in capital letters. And we use this preload. This is used when you want to have some scene previously loaded, so you can reuse it again and again in the code. And in this case, we can copy the path and paste it here. This is the path toward obstacle scene that we previously created, because we will need it in order to be able to create obstacle elements in the in-game. So now the first thing that we need to do is to calculate this area here. First, in order to, we are going to do it once at the beginning, so we do it on the ready function. The viewport area, which is again, is the size of our game window. It's something that we can get with this function, get viewport rect. And we write point size, and this returns the dimensions of this window. And the span area is basic. Well, here, maybe this is not, this is like, let me see. Here we define a max area that is the size that we have, which is viewport area X plus offset, and viewport area Y plus offset. It's like the oops, sorry, I forgot to declare the offset. We also need this dimension, this distance. It's a decimal number. It's basically the distance. And next area, okay, this is a new variable. And the spawn area is the difference between them. The max area minus viewport area. So basically, this is the one. This is the window. This is a max area. It will be this rectangle, and we want the difference. And this is the most difficult slide in the tutorial. So okay, let's go step by step. We want to randomly spawn an obstacle in this spawn area, but we want and so we can split the spawn area in 4 quadrants, and depending on the quadrant, the signs will be different, because if this is the player, everything that is on its left, on their left, it's minus this coordinate, and everything that it's on the player's right is positive. And with the vertical axis, Godot is backwards. in mathematics, it's usually this is the positive and this is the negative, but in Godot, it's the other way around because this is the 0, 0 position. So here will be -1 for the top quadrants and positive or +1 for the bottom quadrants. And we also want that this is a random position, because if we only used it will be a decimal number, not 1, because we want it to appear here or here, different positions, not in the corner. So first, we create a random vector, which will be these numbers representing the coordinates, but it's a float because, as I said, we want it not in the corners, but in different positions here in this area. Sorry. And we also instantiate our obstacle. So well, when the timer reaches its timeout, we create a new obstacle with this line of code, obstacle.instantiate. This creates a new obstacle. And now we calculate the position of the obstacle. So first, we create this vector with random positions that will determine which quadrant and where in the quadrant the obstacle will appear. Which is vector2 rand f. Range between -1 and 1 with decimals. I mean, all the numbers between -1 and 1. And we need 2 coordinates. Too many arguments. I forgot to write range here. So well, we do this twice. One for the horizontal dimension and the vertical dimension. And now this is the difficult calculation. So basically, position is, well, we have this twice because one for the x-axis and one for the y-axis because we did 2 dimensions. It's basically the player position. We want it to appear in relation to the player, because if we don't do this, it will always appear. It could appear only in relation to the window, and maybe the player is far away. Remember that the player moves in an infinite space, and the camera follows the player. So we need to make it in relation to the player's position. So we took this player's position as the starting point. Then we added or subtracted the half the viewport area, because as you can see, this is half the area. It's not the whole area, it's half. And this we multiply by the sign of this, which can be positive or negative depending on the quadrant. So this determines if we add it or subtract it. And then in the spawn area, we multiply it by these numbers that we got here, which are numbers between -1 and 1, decimal numbers. So it determines in which position exactly of the quadrant. And we do this twice. I know this is a lot of code and mathematics. So if it's very confusing, don't worry, just copy and paste this. I'm going to copy and paste it myself too, because I don't want to make any mistakes with my code. Okay, let's be careful with tabs. So it could be in a single line, but it will be very long and difficult to read. So I make these line escapes, and then I tab it to make it easier to read. Timer instantiate not found in base obstacle. Yes, for this timer part, it's not, the error is not part of the obstacle. You probably didn't add this line, so it doesn't know what this obstacle is, and it can instantiate it. Expected initializer after constant name. You have to, this is because in constants you need to add the type of variable. In Godot, since it's in GDScript, since it's derived from Python, and it's not, it can be implicitly typed. You can add these two dots, which means that it deducts the type from the scene. Since this scene is an obstacle, it will know that this is an obstacle if we add these two dots before the equal sign. Okay, so now that we have the position, we need to assign it to the obstacle. So obstacle, since it's a node in the screen, nodes by default have a position. So we write node obstacle dot position, and then, no, don't worry, I already did. I did it here. Obstacle dot position is all these calculations. And now we also need the direction, because we want the obstacle to move towards the player, and we have to dodge it. So we can easily do this by, we access this direction. This one is the variable we created before on this obstacle script here, that we didn't define here. So we define it in the game manager script. And we can do this with this function from the class vector2 that calculates a vector from 2 points. We have the position of the obstacle and then the player position. And this calculates the direction from one point to the other. So we get obstacle dot position dot get direction to. And this is from the player. We want the obstacle to go towards the player. So player dot position. And finally, very important, because when I was preparing the class, I forgot this line, and I was like, why it doesn't work? What's going on? And we need to actually add the obstacle to the game scene, because this creates it, but it creates it out of in the nothing. It's anywhere. So we need to actually add it to the game scene. So we use this function, which is add child. Remember that in Godot, everything is organized in a tree structure with parent nodes and child nodes. So we want obstacles to be children of the game node. So we write add child and obstacle. So it's added to the game node, which is the node where this script is. So, well, let's try it. Well, I got an error, non-existent function get direction. It's because it's direction to, not get direction. Well, this is not something that I made up. In order to, when I was preparing the class, what I did is look at the vector2 documentation in Godot documentation and look if there was some function that would easily calculate the direction in one line. And yes, there was this one. So many times you won't need to, as it said, to reinvent the wheel. There's a lot of functions and classes that do what you need. So, well, this is a pre-made function, as well as this one that's the node to the scene. So now let's test it again. Look, there are lots of obstacles here. So well, they are spawning, but they are infinite. They don't disappear. So as time passes, resources will be used, and the game will eventually crash because there will be too many obstacles. So this is something that we are going to need to solve, and we also want to make something happen, because now if I touch the obstacles, I don't die. But it's already 1 o'clock. I don't know if you want to continue the class. If
I just had a question
yes,
before we go ahead, but I got like an error which says invalid access to property or key position on a base object of null instance.
maybe you forgot to add these 2 dots. This is, by doing this, it knows that it's an obstacle, which is a kind of node, and that it has a position.
Yeah, I added the dots, like I basically copy pasted from the PDF which he sent me.
Obstacle position. instance. Or maybe you don't have this line, but it's difficult to know now what is the error exactly, because it could be different things. Obstacles don't move. Okay, there's people that says that their obstacles don't move. In your obstacle script, did you define the speed? Because if you didn't here, it will be 0, because by default a float, its default value is 0. So if their speed is 0, they won't move. Because it will be multiplied by 0. Or maybe you don't have this line, physics process. Parse player not declared in the carrier scope. Maybe if player is not declared in the carrier scope, maybe or you don't have this line, or either you need to change this to $. You have it like this, and you need to change like this, because in the tutorial I do some slight different thing with player. So make sure you have this line and with $player. Trying to assign value of type game to variable of type player. I'm not sure about this one. For some of the errors, I would need to see your code and your. So if well, first of all, let's see if someone needs to leave because it's past the. In theory, we wanted to do this class from 10 to 1. So maybe, but so I understand if someone wants to leave, it's fine. Yeah, and if someone wants to continue, we can continue for a bit. So yes, we can stay here until 1:30. And my suggestion is that if you have this kind of errors at home, with time you review the PDF and the class and try to do it to review the parts that don't work to see if you find the error, and if you don't, you can email me, and even if you want, you can send me your project or just the script captions so I can look it up, because without seeing your project, it's difficult to understand, because a problem can come from different issues. So for now, I'm going to continue with the explanation, and so let's go continue for a bit. And as I said, feel free to email me with your code so I can review it and give you a proper solution. let's see. As I said, now obstacles are instantiation with no limit, with no limitations. So we have a growing number of obstacles on the game, and this is not very efficient because if the game played for some time, for 4 hours, well, depending on your computer, it will run out of memory and crash, and we don't want this. So we are on obstacle. We are going to create on obstacle scene. We are going to create a timer again. This one, the first one was in the game scene. This one is on the obstacle scene. So with this timer, we define how long will this obstacle live. It could be, for example, 10 seconds. We click on auto start. It could be one shot, but since the obstacle is going to be destroyed, doesn't matter. So we can uncheck it. And again, we go to node and right click on timeout, connect, and we connect it to the obstacle script because we are on the obstacle scene and we want every obstacle to be responsible of its own life. Not this doesn't need to be managed by the game manager. So we have this new function called when timer reaches its timeout, and we add this with three function. I forgot kiwi free. This kiwi free. So this basically what needs is to destroy the node. The node disappears from the scene from the game, and so after 10 seconds, every obstacle dies, disappears. Okay, thank you for the people who, for everyone, and yes, as I said, you can contact me if you have any doubts, and here at the end of the I'm sorry, I'm very tired of the PDF. There are tutorials, other sources where you can continue your learning. And for the people who are here, let's continue for a bit. Well, we have this obstacles disappear now after 10 seconds, and we also would like to make the player die when they touch when the dragon touches an obstacle. So on the obstacle scene, if we go to the obstacle, as you may remember, it's an area 2D, so it's a kind of collision object, and we can manage collisions here. So we can add this one, body enter. It means a body, something, not an area, but a body, like the player, it's a character body, has entered this area. Has entered this kind of tornado on the screen. So we connect it to the obstacle, and there are many. many things we could do for our game over screen, like showing a game over text, going to another screen, losing a life if we have a life system. But here we just reload the scene with this function that you can find on page 42. Get 3 dot reload current C, that will make the whole game scene reload again and start from the beginning. And we can also add a print, so we can see a game over message. So when playing, when I touch, as you can see, the game starts again and there's a game over message. And honestly, I think I won't continue with the tutorial because there are some sections like time, other details like adding a shadow to the dragon, adding music, that they are not difficult, but it's a bit late now, and honestly, I feel very tired. So I think you can look at them at home. And now if you have questions, we can comment on them. And if not, as I said, well, you can look at this on your own and see if you can solve the errors by yourself. And if not, you can contact me, and you can also continue learning by doing some tutorials. For example, we have there's this one. This one is in Spanish, and it's by Rocío Tomé, which is the developer of Watchheads, and where she makes kind of walking simulator game, where you are a character that moves on a screen and interacts with different characters and elements. It's also I think a good beginner tutorial. It's easy to follow. And then there's this one tutorial by Brekis, which is more intense, a lot of information, but very complete too, where he makes a platform game. And then, as a continuation for this tutorial, he has a guide on JavaScript. So if you want to learn more and understand better the code, I highly recommend you to do this, because there's a lot of information on functions, variables, signals, all classes. If you want to learn programming, it's interesting to do it. And on Godot documentation, and as I said, there are tutorials. There's one for 2D game, for making a 2D game, and one for a 3D game. And a lot of information on everything. Like you have here a very thorough introduction on Godot. Here you have the tutorials, main manual for a lot of areas related to the engine. Also was information on how to contribute. A huge community with also more tutorials. The asset library, and you also have all the classes from the game, all the nodes, all the resources. For example, you want to learn more about Area 2D, it's here. You have all the properties, all the methods, signals, and an explanation on them. So it's very complete. And again, there's a lot of articles. People make their own videos with tutorials. There's forum discussions, like someone has a problem. Hey, I have this problem. I don't know how. I can see the error, and people reply and provide answers. There's people who make their own GitHub repository and share their code. lots of online communities in Discord, Telegram. Also, there are courses. Some are free, others are paid in which is like Coursera, or I don't remember the name, on Udemy. Lots of ways to learn about Godot, depending on your needs. And as always, as I mentioned here with forums, it's usually the problem that you have. Someone else had it early, so there's so probably on a forum or somewhere a discussion on how to solve it. And there's also the asset library with assets that people have made and that they share, like dialogue systems or inventory systems or whatever you might need. So, well, a lot of content. Regarding credits, the sprites were made by me too. There are some sprites that we haven't used, like the shadow, some trees, a sprite of a rose too, and others. There's a music track, a copyright-free music that I found that I added in the final version. We couldn't get to use it, but it's there. And well, in the drive folder, you can also find the or in GitHub, if you use GitHub, you can find or in my itch.io page too, you can find the whole project that already works if you want to compare it with your own one. So let me see if there are questions. Okay, here about online communities. I know that in Spain es todo Godot, ¿no? Todo Godot and Godot Spain devs. But for example, when there are game jams, that's also a very good way to learn and to meet other people who are learning too. So I would suggest that if you go to itch.io, there's a lot of jams, so you can find one that interests you and that fits your schedule, because there are jams for just a day or jams that last months. And usually there are Discord servers or other communities where you can meet people and make games together. So it's a good motivation to keep practicing and to learn to make games and to have games made, basically, because in making games, one of the most difficult things is to get the game finished. Well, here I don't know if anyone wants to ask something. Si hay alguna pregunta. So we are going to leave it here. Thank you very much to everyone who came, and I hope you keep learning and enjoy making your own games. See ya.